Welcome to our webinar on Elevate Your Energy Strategy with Microgrid Solution for the Chemical Industry. You will receive valuable information designed especially for the electrical engineers, energy managers, facility and grid operators, as well as decision makers in the chemical industry, dealing with sustainability, CO2 reduction, integration of renewable energy resources, and microgrids. My name is Paresh Todkari, and I'm happy to be your moderator for this webinar. I'm a vertical sales responsible for the vertical chemicals and based out of Erlangen, Germany. And since we receive one question rather often, yes, we will record the webinar and make the recording and the slides available to all participants. If you have already joined one of our last electrification and automation webinars, you will already know the Q&A fields on the upper right side of this application. Please type in your questions to the presenter and Clemens will answer some of them directly after the presentation at the end of this session. Questions not managed during the live session will be answered via email. And just in case you are in full screen mode, press Escape to see the Q&A field for questions and the chat box for short comments. Before going into details, let's look at the trends faced by the chemical industry today. The major trends are sustainability, digitalization, and flexibilization. As we approach critical tipping points for our planet, the demand to accelerate a sustainable transformation has never been greater. Reducing the CO2 footprint in production, reporting on it, and improving a public perception are key issues for all companies. Digital technologies provide new and innovative ways for a business to reach their goals. With digitalization, we may support faster growth and become more efficient and flexible, resilient and sustainable. But driving this transformation faster, easier, and at scale is a challenge for many. Flexibilization of production processes and the trend towards single customer-specific products represent a shift in the chemical industry towards more flexible production processes and personalized offerings. This approach contrasts with the traditional mass production of standard chemical products and opens the way up to entirely new business models. Becoming flexible in the energy mix helps to optimize cost and CO2 targets. In this webinar series, we will focus on the energy transition to renewable resources. Therefore, Microgrid Solutions supports you in integrating renewable energy resources, reducing CO2 emissions while in parallel lowering the energy cost, optimizing power system and driving sustainable growth. In the first part of our Microgrid webinar series for the chemical industry, we are focusing on industry challenges and the introduction of Microgrid solution. In part 2, you will learn more about the required functional packages depending on your application. Now let's have a look at the agenda. We will discuss challenges of the energy transition for the industry. You will learn about a microgrid control functions and SICAM A8000 platform. Then we will discuss cybersecurity and IoT integration for microgrid control. In addition, you may learn from some case studies of industry implementation. Last but not least, we will answer the most frequently asked questions. Our today's speaker is Clemens Wegehaupt. Clemens is a practical pragmatist and passionate improviser. He has been working for over 10 years in the field of microgrids, renewable energy and energy efficiency. He moved from the conservative business of general planning for a large power plants to innovation in the field of microgrids to renewables. According to Einstein principle, if you can't explain something simply, you haven't understood it. He tries to inspire and sensitize people for this topic. Clemens, we are curious to learn more about microgrid solution in the industry. The stage is yours.
Thank you, colleague, for this nice introduction. And I will start in having a look at the situation of the industries today. So the changes and the opportunities for you, for our customers. And we all know it's, first of all about energy consumption. We know that prices for energy are rising. It's combined with somehow the importance of having a look at the CO2 footprint. It is getting more and more important, not only because of the climate change, but we know that there will be taxes on CO2, there will be costs on CO2 in the future. So it's also influencing like the energy bill, the CO2 footprint. Next thing is, compliance to standards, compliance to rules to connect to the grid is getting more and more complex. And last but not least, the life cycle assessment to really having a deep look into how my energy mix is looking like, of which energy is my energy supply consisting, is very important. So it's all about on-site generation and efficiency. It's all about how to integrate renewable energies into my supply in a stable way, how to control these systems to be in line with these regulations, to be allowed to connect to grids, to medium voltage, high voltage or highest voltage grids. And last but not least, it's about energy monitoring and tracking to know my energy mix in detail. So it's more or less always the three topics like process automation, building automation, and last but not least, like our expertise, like our passion, energy automation. And I always describe like Siemens is having these three fields of passion in-house. It's our passion, it's building automation, process automation, and energy automation. And in industries, we always have this three fields existing, available, and our experience is sitting in energy automation. So we are having long years of expertise with how to orchestrate, how to conduct such an energy mix of industrial system in line with these challenges of having highest efficiency available. I will tell you some words about our CCAM applications. So this session is focused on microgrid control. But with the CCAM applications, which is a vendor-independent open approach, we have more possibilities. We have more applications available, starting with PV plant control. PV plant control is focusing on grid codes, focusing on large-scale PV plants, I would say starting with 1 megawatt and really going to, in Asia, we have some cases of close to a gigawatt or even more than a gigawatt of PV in one site. So conducting this plant in way of to be allowed to connect it to the grid in a stable way, like a large-scale plant in the past. We now have renewable large-scale plants in the grid in a stable way. A second application is power management for industries. So especially for industries with sensitive processes, which are requiring a stable supply, we have a possibility with this application to, for example, control a huge amount or set of loads, and we are able to switch or shed these loads in a really fast way to ensure this stable supply of the system. Next application is dynamic load management for e-car charging infrastructure. E-car charging infrastructure is getting more and more important. It's a really booming market. And one challenge is to integrate the systems into our existing grids. So we face some bottlenecks. And this DLM is able to control a set of chargers, a set of charging poles in a way that this bottlenecks, these grid bottlenecks, can be avoided with intelligent control. And last but not least, it's my expertise as I am solution architect for microgrid control. opportunities. And for the microgrid control business, it's microgrid control, so to say. I always describe it the conductor in the energy orchestra. It's always like the focus on efficient and stable supply. In having a set of energy types available, microgrid control is conducting this orchestra. And today we will have a close look, a deep look into microgrid control and how we, with this product, with this application, can help you in boosting and maximizing your energy efficiency and probably lowering the energy bill as well as the the CO2 footprint. All of these applications are based on the same hardware. It's CCAM 8000. It allows a modular approach. We will see that it's vendor independent. And I already told this, it's for energy automation, which is our passion. The drivers for you, for our customers, is different. So we cannot tell that all of our customers have the same drivers. And so is our applications, especially microgrid control. We will see that equipped with a lot of functions in helping these different drivers. We see that here, like starting with economics. So like having a look at the power costs, at the energy bill, at the energy costs at the site. Microgrid control, we have some functions to analyze the costs, but also to lower this energy bill. We will see some function and use cases later. Resiliency, so especially for islands, with having a look at a stable supply. So voltage and frequency is like the rhythm in this orchestra we conduct. It's the most important part for island systems, but also for grid connection systems. If we talk about industrial customers, who are requiring a 24/7 stable supply. And environmental drivers like the CO2 footprint or emissions in general, we will see with having a look at some references, is a very, very important topic. And even there we can help with microgrid control. Regulations are getting stricter. We in Germany, or starting with Europe, we are facing some very tough standards or regulations, being allowed as a customer to integrate renewables in my system and then to connect to a grid. So it's so-called grid codes, which describes what is required to being allowed to connect to the grid. We can help with tackling this grid codes and requirements. And last but not least, infrastructure. I talked about e-car charging infrastructure. We are facing bottlenecks, so grid limits, restrictions. So it's physical, mostly physical restrictions. And with intelligent control, we can avoid this bottlenecks, and we can enable and to integrate this new systems, e-car charging, for example, into this limited existing grids, avoiding, for example, very expensive grid extension. Microgrid control, our conductor in the orchestra. I will describe this picture of, probably you have now this picture in mind, seeing and hearing this orchestra with this conductor in front of this orchestra. And I always have this comparison. So the conductor is like to keep the musicians in sync. So we try to create nice music, and the comparison in the microgrid is voltage and frequency. So balancing load and generation to keep voltage and frequency stable is prior one. It's our priority one, as voltage and frequency is more or less like the stability in an electrical grid. Then we have in this music, in this orchestra, the expression, so enhancing the musical piece. So it depends on which piece it is. You have to keep an eye on as a conductor that this expression is really the right one. And with the microgrid controller, we have also these possibilities. We have different operational modes available, like different expressions in a musical piece. So like a green mode, microgrid control as a conductor is trying to reduce the CO2 footprint, or an economical mode with trying to reduce the costs of my energy mix. And last but not least, resilient mode, so stable mode, to try to have the most stable mix of energy available. Microgrid controller. And last but not least, so the conductor in orchestra has to guide his musicians through the performance, whatever happens. And this we also face, in worst case, with the microgrid controller, so unexpected changes. Like, for example, we require power reserves in the grid, or we face like short circuits, and we need short circuit power and short circuit current available to, for example, keep my protection in a correct operational way. So the microgrid controller is also keeping care, like the conductor, of this guidance through the operation and through the day. So this is always my favorite comparison, my favorite picture. I describe what is the microgrid controller doing, what is his task. So it's like a conductor in an orchestra. And like the conductor in the orchestra, we are, or Siemens is offering a central controller as we see it on this slide. So we have the microgrid controller on, as a central control connected to the available assets in the microgrid or in this industrial grid by using different industrial grade protocols. So our platform CCAM 8000 is flexible. More and more protocols are implemented and integrated in this solution. So microgrid control is through the Ethernet with having some cybersecurity measures connected to the on-site system, to the on-site assets, like if we have it here as an example, like our grid connection, like the loads, batteries, wind turbines, PV, gensets of different type. So we talk about different types like CHP units or like old school normal gensets like diesel driven or gas fired combustion engines. Microgrid control is also offering different ways to have an HMI system available, so a human machine interface. So it is for an operator, the most important part, to have a transparent look, to have transparency of all assets of the energy mix which is currently available, or also of the statuses of the local system. Microgrid control, and this we will see at the end, is also offering like to participate on different energy and reserve markets, which can be an independent business case for some of our customers. And last but not least, microgrid control is equipped with a function that makes it possible to control 4 independent zones, so voltage and frequency zones, with only one controller. Especially for industries, this is very important, as industries mostly having more than one connection to a grid of redundancy and stability security reasons. And it is possible in some cases to split this electrical grid in different zones. And this is what we can offer. We only need one controller to control up to 4 independent voltage and frequency zones. So this was more or less the general picture of this microgrid controller in a real system. In a real system, it's also like this. It's a central controller we see on the slide. It is connected or integrated into the electrical system, connected to the assets. So on asset level, it's on the bottom side of this picture, we see the different assets like our renewables, like PV and wind, like our storage systems, our gensets, but also transformers or switchgear. We are also analyzing data out of, for example, the substation, out of a switchgear or transformer. We integrated this into our system. On field level, we can integrate and use different existing or to be integrated measurement and protection devices. As we are talking, for example, protocols like IEC 61850, it's pretty simple to integrate the data and to integrate these devices into our microgrid control platform. We can use data of existing substation automation systems, like here on the left side here above the transformer, we have the substation automation. We can integrate this into our system, the data, but also we can use the same hardware for both of these applications. So microgrid control and substation automation on the same hardware. Yeah, I spoke about different communication protocols, and like 10 years ago, I started as a commissioning engineer, and I learned that communication and integration of the different assets data is more or less key to a project. So it's, I would like to describe it like 70 to 80% of the project success is won if we can enable a good and a stable communication to the assets. So with microgrid control, we have really, and the CCAM 8000 platform, a very flexible platform, which allows to really vendor independent integrate assets into our system. We can enable different modes, operation modes. I already described this a little bit, like a sustainable mode, an efficient mode, and a stable, resilient mode. And we can more or less with our customers define operational scenarios which are fitting into our customers' requirements. Yeah. The grid connection, important grid codes, I already explained this. With microgrid control, we can ensure being allowed to connect to a grid as we can fulfill different grid codes. And yeah, we can also integrate the different other systems existing. So brownfield or also greenfield, we can integrate new systems if required. Especially if we talk about grid codes. In some cases, it's required to, for example, integrate new measurement equipment with, for example, defined or precise accuracy to fulfill or being able to fulfill these grid codes. Yeah, one integrated system means we can also integrate like the substation automation into one system, like a combined system for microgrid control and substation automation. As well, we can offer and integrate like cloud applications and IoT, but this topic I will explain later in detail. Some of you may ask, so you talked about a central controller, but which type of controller is a microgrid controller? And in electrical grids, we always speak about roughly 3 types of control. So I start with tertiary control, which is the slowest control. And I compare it with a road trip. So a road trip, you have to plan the road trip before. So you have to choose which roads are you going. Probably if you own an e-car, if there is charging station alongside the route. And this is tertiary control. This needs minutes. It's not fast. So you have your map in front of you, you plan your trip, probably with some nice breaks at some nice locations, tertiary control. Secondary control is then in the car. You're driving and you as a driver is giving the command for the speed setting. So it's like in seconds. So it's slower control. And the most fast control is primary control. So think about you have set your cruise control in your car. The primary control is adjusting the throttle. It must act really fast in seconds to get all situations covered, like if you go up a hill or down a hill, to adjust the throttle in a way that your speed is kept stable. So very fast control, mostly sitting as a primary controller in your car, in your engine. So microgrid control is sitting in the secondary control level. So we are caring about like power and load sharing, like asset management, like keeping an eye on the statuses of the different assets, statuses like voltage and frequency to keep it stable. We calculate set points for primary control and we send it to the primary controllers. Microgrid control as a secondary controller. Yeah, microgrid control. I lost some words about this platform, CCAM 8000, which is historically coming from substation automation, from energy automation. It's made for energy automation, and this makes it a perfect fit for microgrid control. The hardware is equipped for any task. It's a modular approach. So here is some examples. So the possibilities are huge. I cannot show it in this short webinar, but have a look at YouTube. There is a lot of videos and nice presentations available about this really great platform. So we have different possibilities in connecting this system into your Ethernet or your network, in having different Ethernet communication modules. We have different processor modules available which can cover really up to the most complex tasks, which are requiring really high performance in calculation in this processing units. Then we have different expansion modules available, which allows really a huge set of communication I/O modules to be integrated in the system, as this system is also used in substation automation with sometimes hundreds of different I/Os which are required in the project. So it is equipped for every task. It's really flexible. It's open. And with Siemens as a partner, we can really go to a tailor-fit, a perfect solution with having this platform for microgrid control. Microgrid control, and we as Siemens, we are seeing cybersecurity as a topic which gains in momentum, which is really important. If you have a look at the news, television, or use Google, so cybersecurity is very, very important, especially for industrial customers. So your process, your products are your gold. We have to protect this also from attacks from outside. And with CCAM 8000, with this platform, we are equipped with really the best fitting tools, and our mechanisms, our possibilities in case of cybersecurity are always following the latest cybersecurity standards. I have some examples here. So we have a built-in firewall available. The whole communication can be encrypted end to end. We can secure the communication with different certified protocols. We can have a firmware signature to avoid or to prevent that a man in the middle, for example, or a third person is adapting your firmware without letting you know. We have a signature for this firmware. We have role-based access control. We have TLS encryption if required. We are compliant with the latest BDV white papers, for example. Everything can be, so all steps can be password protected. And last but not least, with the security logbook, you can log every measure in cybersecurity or in the communication. We will see that. I have one example with me. So you see, we have a lot of tools and possibilities available, but I always tell there is no out-of-the-box cybersecurity system in the world. And one advantage in going with Siemens is we as a partner, we can define, we can work out, we can create the best fitting cybersecurity concept, and then adjusting these different tools to really fit into your requirements. One example of those cyber attacks is like this, to detect intrusion. This is somehow a small challenge. Our product is equipped with a possibility to have this automated. So our solution can detect an attack. So like this intrusion into my system with using the security logbook and automatically detecting if there is an attack. Plus, and this is this example you see here on this nice picture, we can also integrate like IT untypical information, like here a door contact. Sounds a little bit strange, but this type of attacks is changing. So like the dark side of power is adapting to the possibilities in cybersecurity. And there was one example like in a server farm, not the servers was attacked directly, but the air conditioning. So air conditioning, if you bring it down, probably you know what happens. So temperature is rising in the server farm, and for me, as on the dark side of power, in best case, I make it that the servers has to ramp down or to shut down because of the rising temperature. We, with our SICAM 8000, can also integrate like statuses of an air conditioning system in this analysis, and we can also detect then, okay, there is something wrong, please have an eye on your air conditioning, and probably we can prevent those situations. SICAM 8000 is equipped with some really nice possibilities also regarding HMI, visualization, displaying of information for the operators, for probably your visitors, for probably your management. We have the possibility, for example, with SICAM Web, it's included in the hardware. No other licenses are required. It's coming with the hardware, and with SICAM Web, for example, we have one example here. We can integrate like own pictures like single lines. We have one example here. It's a vector graphics. You can adapt it independent of Siemens with some open source tools available in the internet. This HMI is also equipped with a lot of security measures, a lot of security mechanisms. We can implement a user management system. There is an advanced diagnostics or possibilities to have advanced diagnostics available. This was also one thing I saw, and it was really great to see this. As I have explained, I started in Siemens like 15 years ago as a commissioning engineer, and with these possibilities, really the commissioning, the engineering, and also the maintenance is made really easy. You can really detect malfunctions or bugs really easy, and with, for example, an Ethernet capturing tool, it's really great, and this work and is made more efficient than without these tools. With microgrid control, we have even more possibilities. So SICAM Web, it's more or less our basic HMI for the lesser complex projects, or also cost-wise. So without a license and so on, cost-wise, really efficient solution. Plus, we have the possibility to scale this HMI or to equip this HMI, for example, with long-term archives to make it more detailed. And therefore, we have the possibility to add as an option SICAM SEC. It's a WinCC-based software, also coming from substation automation. It can be used as a basic SCADA system, so we can integrate like statuses of your protection equipment, of breakers, of transformers. Here on this picture you see one example. You have on one view an overview of your energy dispatch, of your CO2 footprint, for example, how your different assets are behaving, how your different assets are controlled. We have a long-term archive available, which makes it possible then to analyze the data after a certain period in time, and even fine-tune then your system. Or think about, you start, for example, in the integration of a PV system. You see, okay, that's a good thing. My energy bill is lowered. I have really, I can use this energy coming from a renewable source, but now I play with the thought to extend my system with a battery and so on. And we can use the archive data, for example, to do some, studies, and how to make your system even more efficient. All these parts is available as loose components. So for customers with an existing system, existing cabinets, probably an existing storage system, storage device, we can integrate the components in the existing cabinets. But we have also one really efficient, I like this really much, this solution, a pre-bundled package. Not only in case of our functions, which we will see later, but in case of the hardware. So we have pre-bundled packages available. It's a so-called MAB box. So it's a multi-purpose automation box. It's available in different configurations. It's one solution, one global design, available in different manufacturing sites around the globe. We can adapt it with you to fit your requirements. And it's space saving, it's pre-wired, pre-tested, pre-mounted with a full documentation. And this makes it simple in case of commissioning, but also then later in case of extension or maintenance. So documentation is worth gold, and with this, and I think we have everything in one place, and also in 10 years, you know where which wire is leading to, and you're able to maintain then the solution more simple than a specific solution without some documentations. And believe me, I saw some of these cases. So this is a really chance for you, for our customers, to have nice hardware on site. Yeah, IoT integration. It's one of the most important, besides the cybersecurity, if we talk about the connection to the internet, to the cloud, how we tackle that. If microgrid control, so the CCAM A1000 based platform, can be integrated in this IoT world, in this cloud world. And we have some possibilities available. Beside the possibility to connect our system to a third-party cloud application, it's possible. We have some communication protocols available. We have gateways available to connect to even third-party cloud applications or cloud systems. We have our own one. We can offer, based on Electrification X, that's the name of this IoT suite for electrification and automation. We can offer different functions, different possibilities. But there, I point out, even for Electrification X, there is really nice videos in YouTube and presentations available. Please have a look at the possibilities having or integrating this nice platform. Yeah, I will now have a look at the different microgrid control functions. And I will start in giving you a picture of the types of functions we have available. So in microgrid control, we have different function blocks available. So all of our functions are bundled in blocks, object-oriented blocks, and we have functions. I describe it as overall control functions, which are made more or less to influence the behavior of your whole system, so your whole site. One example is, think about your site is one cell in a supplying grid or in a larger grid. And you were told to behave like a generator, so to say. So to inject power into the grid, or to take power out of the grid, or staying neutral. So the overall behavior of your system is influenced. So this is the overall control functions. And we have asset-specific functions. Asset-specific functions means, for example, control of battery storage systems. How this system shall be or must be controlled, that this integration in a stable way is possible. This is meant with asset-specific functions. And in microgrid control, we have a lot of functions available. So don't be shocked about this really packed slide. So this is this overall functions. So like, for example, with our control modes for economics, stability, for example, for having always a real-time analysis if my system is still grid connected or if I am acting as an island because of a grid blackout, for example. For example, the analysis, real-time analysis of spinning and short circuit reserves or short circuit power. For example, asset maintenance is monitored in real time in your overall system. Different energy and power schedules are available. Forecasting functions are available, plus some functions regarding market integration or market interaction is available. So we have a lot of options to really fulfill your requirements and to tailor fit a solution which fits 100% your requirements in a really cost-efficient way. Yeah, one example of such overall function is the power schedule. So we have a small microgrid here with different generation sources. In the past, we had a load profile which were given by the load or the process. Here's one example of a heavy industry or any other industry you can think about. And this power schedule, if it's implemented, you can try to more or less change this load profile towards a supplying grid. Here's one example, this green line. And the microgrid controller is then using the underlying or connected assets to try to fulfill this change of the load profile. For example, I switch on or ramp up generation sources if I would like to cut off a peak or lower the load profile over a certain point of time. So here in green. Or in yellow, I charge batteries if I must get rid of energy in my grid, and so on. And with that, my load profile is adapted to a given schedule. Where the schedule comes from, it can be parameterized manually on the HMI, like the CCAM Web or the CCAM SEC, or it can also be received over FTP protocol from an external source, like a DSO, for example, or a market tender. Different possibilities are given. One example for such overall function. Plus, asset-specific functions. The asset-specific functions, I talked about batteries. One nice example is controlling batteries. We have different more functions available, but for example, SOC balancing is one of the best examples to explain what is an asset-specific function. We have different other functions, asset-specific functions available, like for example, automatic start of gensets, like droop mode or droop control to calculate the droop settings for different droop controlled assets like batteries and so on. One example is like this SOC balancing. SOC balancing plays a role in systems with different storage devices, for example. In this example, it's a really simple example. I have a large battery and a small battery. So in an unbalanced world or in an unbalanced system, it means that the large battery with a huge capacity is discharged slower than the small battery. If no one coordinates the commands to these batteries, the small battery will always be discharged first after the large battery. This means that also the lifetime of the small battery will be shorter than the large battery. Probably a really simple example in practice and the real world. It will look a little bit more complex, but I think it's a good way to understand the principle of this function. And the principle of this function is to balance out the commands to the small as well the large battery to ensure that both of the batteries are charged in the same speed. To also ensure that the lifetime of both batteries is made, hopefully, in best case, equal. That both batteries are stressed the same. This is SOC balancing, and this is one example of this asset-specific functions. Microgrid control with having this huge set of functions can cover a lot of challenges in industries, and I will give you a picture of some real-world examples, some really practical experiences, some references, and our most known, most nice, I would like, because of it's really showing the way of an idea to really the practical implementation is Lemene. It's a commercial campus in Finland. We started some years ago, but it's still ongoing. They started in having this industrial district we see on this picture. It's a huge industrial district with this nice shopping mall in the middle. And this shopping mall has to be supplied with thermal power. yeah, as well as electrical power. And the customer started years ago with having this idea, if it's possible to operate the system as a pure electrical island. And it is. So we have integrated a battery there. And with this battery, it was possible, together with the gensets, existing gensets, for example, supplying this shopping mall with thermal power, to ensure that the whole industrial district can be operated as an island, even in case of a grid blackout. Was possible. The customer then thought, if it's possible to extend this case, yeah, to in best case create a business case to earn money with, for example, these batteries, and it was. So we have implemented like a market interface to different markets, like a reserve energy market, and the customer is earning now money with the existing microgrid system. So it's a perfect example from moving from an innovative idea to really a practical implementation. On this picture, you see the structure of this system in Lemene. So as I have explained, we have to supply two different energy worlds. One world is the electrical world, and the second world is the thermal world. The microgrid controller is having those functions, so controlling the electrical demand and also the thermal demand. We have some CHP units in the system. We have also PV in the system. We have small fuel cells connected in the system, which are controlled by the microgrid controller, and the whole system is measured. And as I have explained, from an idea to really the practical implementation, and even more to new business case. So this is really possible with microgrid control and having these different functions available. So in this practical reference, we see that these drivers I explained in the beginning, like energy costs, like increased resiliency, like renewable integration, like participation of energy markets, but also this regularity challenges, like these grid codes, can be tackled, can be fulfilled with having the possibilities of microgrid control and CCAM 8000. Yeah, the compounds there, so we used the microgrid controller to integrate all of the systems in this nice solution, and it's always nice to see this reference. Big reference, Lemene, industrial customer, but we can also cover like smaller systems or supply smaller systems with our solution. And one nice example is Upper Blinkwater. It's a community in South Africa. It's different to Lemene. So Lemene is an industrial district. Here we have residentials. So people are living there. The challenge is there is no grid connection available, and so we have to ensure that this system is supplied with energy 24/7 in a stable way. And one use case or one idea, one requirement was to lower the fuel savings. This system was supplied in the past purely by diesel gensets. The customer thought if it's possible to extend this diesel gensets or to build like a hybrid plant or a hybrid supply. Hybrid means I mix my energy generation, so I put different types of energy generation, and the customer here put it PV generation plus a battery storage system, and we build it like a hybrid plant, a hybrid supply for ensuring to supply this residential loads, residential customers in an off-grid scenario. So purely off-grid, without grid connection, microgrid controller is ensuring that this system is controlled and kept stable. Yeah, the features is monitoring and alarming, very important. So if something is wrong, if, for example, in PV inverter fails or a CHP unit or a genset is tripping, then an alarm is generated, the customer is informed. We have a load shedding scenario, for example, if battery is empty, worst case scenario, CHP or genset is failing, then loads can be shed, for example, non-critical loads, plus we can operate fully off-grid. Yeah, the key takeaways of today's session. Why microgrid control? Microgrid control allows really enhanced resiliency with economic benefits. So to say, you get a little bit more independent of a supply, of energy supply. We have industrial specific solution, pre-packaged solutions available, which allows the stable and reliable supply. We will see that in the second session. Why CCAM? It's a modular platform. It's future-proof. The world of inverters, of electronics is really, really dynamic. Not only communication protocols are changing, devices are changing. We have fuel cells, we have new technologies, which is really great. With CCAM 8000, you can be sure you have a platform which allows the integration of different of these new technologies. It's proven and reliable, as it is used in thousands of projects around the globe. In substation automation, but also in energy automation and microgrid control. It allows robust security. So robust security, we talked about cybersecurity, but also it's possible to build like fully redundant systems for industries, for example. And why Siemens? So I'm really proud to work for Siemens, as Siemens can be a perfect partner and can work out a tailor-fit solution for you. So it's then a cost-efficient solution. Probably not the cheapest one, but tailor-fit and covering all of your requirements. It's seamless processes, so we will not leave you alone, so to say. We are more or less one of the leaders of sustainability. And last but not least, we can be a long-term partner, and you can be sure that we are still there also after years. So it was really an honor and a pleasure to explain this solution, this platform to you. And now it's time to ask your questions. So it's now the stage is yours. Ask your questions. We will try, or we will do our best in giving you a good answer. Thank you very much. I'm really looking forward to your questions. Yes, great. Yeah, your questions. What is microgrid? So yeah, the topic or term of microgrids, years old. Microgrid could be a lot of systems, but all in all, it's a system which is able to supply itself with energy. It can be an industrial system of usual medium-sized, large-scale industrial customers, can be a campus. I would explain a microgrid is a system with more than one energy source and a combination with loads and one instance which tells the system how to behave to the outside world as an island, consumer or producer or a mix. This more or less is microgrid. Yeah, the next question, for off-grid micro hydro, is possible to apply this controller and what's its price? I think the background is like if it's valid for hydro or run river systems. I don't know if I understood the question correctly. We can integrate such systems, yes. And yes, it's also able to apply off-grid systems with the microgrid control, as it is coming from this application for island systems as an electrical secondary controller able to conduct voltage and frequency in such off-grid systems. And this leads me to the next questions. What do you mean with calculating secondary settings? Yeah, the secondary control, which is the second slowest or the second fastest control in our grids, is usually calculating like set points, like droop set points, like the steepness for voltage and active power, or frequency and active power, voltage and reactive power, sending it to the different controllers of assets like batteries, which can be controlled in droop mode. So it calculates set points for the different assets, keeping the system stable. Yeah, and hydrogen could also be one, so a hydrogen system, a hydrogen production plant, which is seen from our perspective as an industrial customer. Yes, we can also equip such systems with our microgrid controller, and we can integrate it with, for example, process automation systems or different other external control systems. Yes. Yeah. Same thing for the next question, with a combination of green hydrogen and PV, and mostly battery, because you have to supply the hydrogen process or generation process in a stable way. So it's mostly a combination PV, battery, and hydro as a load. Same answer. We see it as a solar panel installation and challenges. I can take this question. I will try to find the correct contact person. And thank you for this question. I try to answer it by contacting the right channels or persons. Yeah, how microgrid will deal with PV plants? Yeah, PV plants, we like possible around 1 second to shed loads, because we have to consider like measurement cycles and so on, reaction times. I cannot give a general answer. This has to be really analyzed specifically, but I would say 1 second and more, around that. Yeah, you can switch off loads in a coordinated way. Yeah, what are Siemens competitors in power plant control, and how Siemens stands out in that? So we stand out in that I think Siemens is a really one of the best long-term partners you can get in your journey to sustainability or stable energy automation. Yeah, the next question, if there is an example of PV plant controllers, battery controllers already connected to CCAM microgrid control. Yes, we have a lot of examples available. I would be happy if you can give us this question in written form via email. We can then select or see what's available in our documentation and can answer this then specifically. But yes, there is a lot of examples available. Yeah, longer question. What are the type of alternative solutions available to households in African regions? I already answered this question. Yeah, please have a look at Upper Blinkwater, and if we can follow up with a mail, I can then forward it to our respective business developers or sales responsibles in your region, and we can have a look at your specific request. Yes, next questions. Are there any plans to start working with DM in a microgrid? I think, is it device manager? I'm not 100% sure. Yes, we are now transferring from toolbox to device manager. We will need some time for this journey, and you get this news as soon as the new microgrid control on device manager is available. Thank you. Yeah, next questions. How many maximum load groups can be connected? 30 groups or 30 loads? You're absolutely right. It's 30 groups or 30 loads. So you can connect 30 breakers or 30 feeders directly with controllable breakers, controllable devices. So using one set point per feeder or breaker. Or also you can use like a connection to a process or a building management system, which then is able to group loads into one, and then we can control up to 30 groups. So we have 30 flags or 30 set points available to control or to do load management. Next question. Is CCAM controller adapted and ready to deal with protocols of other companies? Yes, it is. And this is one of our biggest advantages. It's an open platform. And it's the huge set of communication protocols available on the CCAM platform. And there I would like to point out or refer to the CCAM A8000, CCAM S8000 official webpage, for example. There is a lot of information available also in the SIOS platform. You can find the handbooks for the platform itself, and there all of the available protocols are described, and it's getting more. Stay tuned. Yeah, next question. How can set right frequency fluctuation? Yeah, the answer is secondary control. So I already have explained this. So as a conductor in the orchestra, electrical orchestra, we measure voltage and frequency of the internal grid, if off-grid, and we are acting as a secondary control, sharing then set points to the different assets to keep the system stable regarding voltage and frequency. Yeah, the next question. A cloud-based solution is available in microgrid control. Not in microgrid control, but on top of microgrid control. And I'm really proud and I'm really looking forward to our colleagues of Electrification X. There is also like a lot of webinars and informations available. If you follow to the official webpage of Electrification X, this is our cloud platform for, the integration of, for example, several microgrid controllers, if you have several. Yes, the next question. How does microgrid integrate with existing power grids? Yeah, brownfield approach. This is one of our advantages. So our microgrid controller is a perfect fit for existing plants. And the majority of our projects is brownfield plants. So we integrate like smoothly in brownfield plants. And this is also like the answer on the available communication protocols. We have a lot of communication protocols available. We have also the possibility to use hardwired signals, like analog signals or digital signals. So we can integrate also in existing environments specifically to be analyzed, but absolutely possible. Yeah, and I think the last question, how many loads in one group can be connected? This is a question then, towards your specialists in building management or process management. There's a lot of systems available. I have worked, for example, with a Siemens system like C-Compass, and there was no limitation in grouping signals to one. Yes. I think no more questions. I'm really happy. Last question. Any use case for hydrogen-based fuel cell integration? Yes, hydrogen, so fuel cells, we also already have integrated in microgrids, and it's seen somehow like electric acid. So if you have some information or if you have a specific fuel cell you have in mind for a concrete project, please forward us this information and we will be happy to check the possibilities. Thank you very much. I think very good. Thank
Dear auditorium, thanks a lot for your questions and thank you to Clemens for all your answers. Still open questions in the Q&A queue will be answered via email. And if questions come to your mind later, please contact our specialist. I'm sure they will get back to you soon. In the upper right-hand corner, you find the microgrid for chemical industry